Hi, everyone. We are the Shaggy Dogs, and we're comprised of Alex Stately, Belen Lopez, and myself, Whitney Liebenow. And today we'll be going over our NYC licensed dog analysis that we are looking to deliver for our final capstone. So our overview of analysis, the reason why we selected this particular topic is because we do have a deep-rooted interest in determining whether or not there was a surge in active dog licenses between the years of 2014 and 2016. We also were looking to seize the opportunity to analyze multiple variables that was included in the data, including dog breed, name, owner's borough of residence, and the correlation with owner's income by household that was derived from the US Census Bureau. And last but not least, who doesn't love dogs? So the data that we used throughout this project was an NYC dog licensing data set that was derived from Kaggle, but the parent data set actually lives on NYC Open Data. It's comprised of 122,000 rows and 15 columns. We also used an income by location data set that was derived from the US Census Bureau, ACS, and it does have 14,000 rows and 8 columns. So in this presentation and throughout our project, we were looking to answer 3 objective questions. The first being, is there a correlation between location or borough and dog breed? Second, can we predict dog breed or dog name for each neighborhood? And third, does higher dog ownership exist in more affluent boroughs or census tracts?
The technologies and languages we used. For languages, we used Python, HTML, and SQL. The tools were Tableau, Pandas, and sklearn. And then as far as algorithms, we have random forests.
So the Kaggle data that we used already had a lot of cleaning that was done from it from when it was pulled from the New York open source data. But we still had to do some initial analysis to remove null values, as well as to make sure the data set suited what we needed to analyze. A lot of the dogs had name not given or unknown. These are removed because they were unhelpful for our analysis. However, unknown was left in for animal breed because there are several dogs that do have an unknown breed that is a known type of dog. So after cleaning this data set and removing these null values, we needed to check how many rows we had left, how many dogs could be found across each of the 5 boroughs, which borough had the most dogs, and then try and see if we could see a distribution of names or dog breeds across these 5 boroughs. And the visualizations for these data questions are in the following slides.
So for dog breed results, the first chart here is dog population by borough. This shows that the highest population of dogs is in Manhattan at 41,327. And then the least amount of dog population is shown in Staten Island at 10,865. Next, looking at the top 10 dog breeds in New York City, Yorkshire Terrier is at number 1 with 7,358 altogether, and it's followed by Shih Tzu at 6,848. And then Pomeranians had the least amount at 2,029. And then looking at the third visual there, it's top 5 dog breeds per borough. This shows that it goes along with the second picture there, where Yorkshire Terrier is number 1 for all boroughs besides Staten Island. You might not be able to tell because there's only 6 dog differences, but in Staten Island, Shih Tzu is number 1 at 6,848 Shih Tzus there. And then followed that is Yorkshire Terrier. Looking at the dog name results, the top 15 dog names are listed right there, starting with Bella, Max, Charlie, and so on. And then if you look at the second table, top 3 dog names per borough, you can see there that out of those 3 top names, Bella is number 1 for the Bronx, Brooklyn, and Staten Island. Charlie is number 1 in Manhattan, and Max is number 1 in Queens. But those are the top 5 or the top 3 dog names per borough.
So in our database development, we created this entity relationship diagram that housed all of the data that we were looking to explore to answer our objective questions. So as Belen mentioned and Alex previously, we use the NYC dog data as our parent data set that was linked to borough dog genders, borough birth months, income by year by census tract, that also joined to our income dog data, and then borough license dates, dog names, and breed names as well. Previously, the data did not come with a unique identifier. So one of the things that we needed to implement into these data sets is a specific UID. And then for our income by year by census tract, we used tract float numbers as the unique identifier. Our income results. So one of the highlights of our project was analyzing average income data for households within the 5 boroughs based on census tract, derived from the American Community Survey. So each of these census tracts correlate to each of the 5 boroughs within New York City. And the years that we were examining were 2014 through 2016. So each of the columns here show the average household income for those 3 years, as well as the average household income across all 3 years. One thing that we did notice about the data is that for New York City, each of the counties use the same tract numbers across all counties, which made it hard to differentiate income for each of the 5 boroughs. But we were able to determine average household income for tracts as a whole.
So 5 different supervised machine learning models were tried out to analyze if we could predict which borough the dog came from based on the other information that was given in the data table. Supervised learning was chosen because we knew which borough each dog was from. So we had a actual target variable that we were looking for. And then all the other identifiers, zip code, census, and some of the congressional tract district columns were removed because obviously these would correlate with which borough the dogs are from. All of these models had unfortunately a really low accuracy score. Part of that is based on, in the previous slides, you'll see with the distribution of dog names and dog breeds, most of the boroughs have a very similar top 5 dog name and a top 5 dog breed, which made it difficult for the machine learning model to distinguish which borough the dog was from. The 3 models that performed best were random forest, gradient boosted, and SVM. SVM took a lot of processing power on my computer. I had to run it in Google Colab notebooks to make it work. So even though it had a slightly better accuracy score, it was disregarded because of how long it took to run. Gradient boosted was also really good. Unfortunately, I couldn't get it to work with the explainer dashboard, given it had more than 2 categories. So the random forest analysis was chosen, and it was then integrated with the explainer dashboard and integrated to our presentation dashboard. So here's the confusion matrix for the random forest machine learning analysis. You can see that the model does the best predicting dogs from Manhattan. This is because the database had Manhattan had the most dogs supported in that category, and then Staten Island was the worst borough that it was at predicting because Staten Island had the least amount of dogs in this data set. So when we check out which feature is the most important for this model, we see that breed name is actually one of the most important features, next with animal name, and then license and gender and animal birth month are less important for this classification. So here's just an example that I pulled from the explainer dashboard. This is just a random dog from our data set. And then you can see the distribution of how the model is predicting which borough the dog is from. This one it chose correctly. This dog is named Elvis. He's a Pomeranian from Manhattan. And the model predicted this with a 35% probability, but you can see that it still has a high probability or a higher probability for Queens and for Brooklyn, and a low probability for Staten Island and the Bronx. So even though this animal was predicted correctly, that's still not a very high accuracy score. It's almost random, basically. So there's several things we think that we could have done differently. This dog's data set only went up to about 2016, 2017. We were really hoping we could see the trend of all the people buying dogs in 2020 during the beginning of the COVID-19 pandemic. So if we could find an additional data set to supplement our data set, we could possibly see that trend. And then we had a issue, as was explained previously, finding the right census tract for each borough. So next, one thing we might do is pull the US Census data by county, as opposed to a lump sum, because that might have a better integration into our data set. And then possibly, instead of using a supervised learning model, using a neural network classification, as that might be able to better predict the data set. However, there are a lot of unique categories for dog names and dog breed, so that might make it difficult for the neural network. And thank you everybody for listening. If you have any questions, feel free to ask us.
Thank you.